The third continuous probability distribution that we're going to look at is called the exponential distribution. The random variable here is duration of time or space. Okay, this is similar to Poisson. It's actually the inverse Poisson distribution. Remember, Poisson is how many successes occur in a space of time, unit space of time, whatever that unit is. Okay. Here it is the inverse, that is, what is the time between two successive events, duration of time or duration of space. Okay, that would be exponential. So if the number of instances random variable follows Poisson distribution, then the time space between the events will always follow exponential distribution. So the exponential distribution and Poisson distribution are kind of married to each other. They can never be separated. So here are some examples. Duration of customer service call, time till the machine breaks down, so it's a time, distance traveled in one full charge of a battery. All of these can be examples of exponential distribution. Once again, the condition is same as in Poisson. In Poisson, remember, the average rate is proportional. So if the average number of arrivals in 1 hour is 5, in 2 hours it has to be 10. In 3 hours it has to be 15. So it has to be like that. So same holds here too. The probability between the rate should be this. Okay, the PDF function, probability density function. It's actually just PDF. Probability density function is this. Okay, and x is the random variable, and that's the duration of time. So now theta is the mean of x. Okay, so if x is duration of customer service calls, then theta is the average duration of customer service call. Now if you take a reciprocal of theta, 1 over theta would be the average number of events per unit time. And this will be like lambda in Poisson distribution. So you need to have this, so then you substitute mu in here, and you get the probability density function, so which is the curve. The curve would be the exponential curve will look something like this. Okay, so it's a curve like that. So here there are some examples of what happens to the curve when value of theta changes. So smaller value of theta is more spiked like that. Larger value of theta is more flattened out like this. And once again, since this is a continuous random variable, the probability is the area under the curve. It's not the height of the curve, it's the area under the curve. For a particular value of x, the probability is 0, like what we have discussed before. And through calculus, we can find that the probability, cumulative probability, is given by this function. 1 minus e to the power of minus mu times t is the value for the random variable. Okay. All right, let's look at an example now. Suppose if we have a muffler shop, okay, and the service time to install a muffler follows exponential distribution, right? And mu is per hour, how many? So if you're given mu, then we can find theta. If you're given theta, then from theta you can find mu, right? So the mean is given as 3 mufflers per hour. This is a problem from the textbook. So then 1 over mu will be equal to theta, so that's your mean service time. Okay, what is the probability that the time to install a new muffler will be half hour or less? So we want 0.5. Okay. So this formula gives you the cumulative probability, right? So you have 1 minus exp, okay, e to the power of minus mu times t. So that will give you the probability of installing within half an hour. Yeah. And what is the probability that the time to install a new muffler will be more than 40 minutes, right? So you have to be very careful. So this mu here is per hour. Okay. So either you have to convert this mu to minutes. So if mu is 3 per hour, what is mu per minute? Okay. Or you need to change the t from 40 minutes to hours. So we'll change this to hours, right? So we want what is the probability that it will take more than 40 minutes. Okay. So first, if you apply the formula from before, okay, like that formula, so we needed to have that absolute reference, so we can copy. Okay, so if you copy that, so that will give you the cumulative probability. Okay, x less than or equal to t. But what we want is the other side, okay, greater than 40 over 60 hours. So that will be 1 minus